So to gear up for what we're going to do next, let me talk with you about some summation formulas and properties you may not be aware of, because we don't work a whole lot with summations, and we're not going to have to work a whole lot with summations, but I like to go through one thing to kind of show you a remarkable thing about what we're going to do next. But anyway, these summation properties, number one, there's a couple of formulas on summations that you may be aware of, maybe not. But number one, on the handout there I've given you, yeah, it turns out if I'm summing up the i's, which basically what this means, I runs 1 to n, so it's 1 plus 2 plus 3 plus 4 plus 5, all the way out to n. If I'm adding up that, it turns out I don't have to add up all those numbers. I don't have to add 1, 2, 3, 4, 5, all the way up to n. I can just do this, n times n plus 1 divided by 2. So it shortens it quite a bit. For example, yeah, I got I equals 1 to 10. That equals 10 times 10 plus 1 divided by 2, which is 10 times 11, which would be 110 divided by 2, that's 55. And you can check that one pretty easily, because this just means 1 plus 2 plus 3 up to 10. So it's just adding up the first 10 numbers. But if you add those first 10 numbers up, sure enough, you get 55. Easy to check that one, but it works out pretty nicely. And so you can do large numbers very easily if you're doing just adding them up. What would that be? We do I equals 1 to 1,000, the summation of the i's. Well, it would be 1,000 times, so we do the n times the n plus 1, so it would be 1,000 times 1,001 divided by 2, which that's going to be 5,500, I believe, depending on that. Is that right? 1,000 times 1,001, then divide that by 2. Is that 5,000? 500,500? Yes? I think so. So I just added up 1,000 numbers right there in about a second. All right, so you can see the usefulness of it. Now, we won't necessarily evaluate for a particular I. We'll just use this formula in what we'll do next. But you can do that. You can add up those numbers very quickly. Well, it turns out there's a formula also for the I squareds. I equals 1 to n of the I squareds would be n times n plus 1 times 2n plus 1, and then divide that by 6. So it's a little longer formula, but it's still pretty short and sweet. So if you're adding up the I squared, so if you're squaring the i's, so 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared, all the way out to n squared, you don't have to add them all up. You just do the n times n plus 1 times the 2n plus 1, whatever that is, and then divide by 6. And we're not deriving these formulas, I'm just telling you what they are. We can't. We needed to, but. All right, then interesting one on the I cubes, 1 to n, summation, of the I cubes. Look at what it is. It's n times n plus 1 divided by 2, but then you square that. Interesting enough. So it's the I, if you will, formula, but you square that number. So if I did this one I cubes, it would be that cubed. So that's going to be quite a large number, but anyway, interesting little fact there. All right, then number 4, we got the summation I equals 1 to n of c. Well, again, using our usual rule of thumb there, c is just a constant. So in other words, this is just a number. Well, it turns out it's just that number times n would be the summation. Why is that? Well, think about it. The first term is c, then the second term is c. The This is just saying you're adding up C n times. So we've got n of those C's, right? Wouldn't that equal C times n? Yeah. Anyway. All right, number 5 on my sheet. So I got I equals 1 to n. Then I have A times f of I. That equals A times the summation I equals 1 to n f of I. Well, that again, it's just kind of a factoring deal, because if you write out the terms, that'd be A times f of 1, and then the second term would be A times f of 2, right? Because I'm just plugging in subsequent i's there. And then the third will be A times f of 3, all the way until you get to the nth one. Well, isn't that A a factor on all those? So really I'm just factoring off the A for this formula, that's all I'm doing. Right? I can factor off the A, that's all it, and this is the summation of the f of i's, that's all it's saying. And then number 6 is I equals 1 to n f of I plus g of I. You can just do those separately. Do the f of I summation and then the g of I summation separately. And that's just kind of reordering it. Yeah, so instead of doing these together, you can do them separately. That's all it's saying. And it works for minus as well. Okay, so that being said, let's simplify some, because this is what we're going to do next. Let's simplify the summation I equals 1 to n A minus B over n times I plus C squared. I don't know why we're so far over there, but okay. Well, it's using these properties as we can. Well, isn't this 2 things added together, which is number 6? 2 things added together, I can do those summations separately. So I can do the summation I equals 1 to n A minus B over n times I plus the summation C squared I equals 1 to n. So I'm just separating those by property 6 here. Now property 6, I can separate those. Okay? Now what can I do? Well, so this, what we have to note here is that our index is I, so that's the variable, if you will. The I is what's varying. That doesn't have I in it, so it's not a variable, it's a constant. It's like this one, you see, property 5. That's just a constant in front there. I mean, it's not just A, but it's a constant. A is just some constant. That's constant because the index is I. So I can pull that out, so it's A minus B over n times the summation I equals 1 to n times I. That's by property 5. Now, what can I do with this? Well, C is also a constant. It's squared, but it's still a constant, square constant. Isn't that property 4 here? If you've got a constant summation of a constant, it's just the constant times n. So isn't this going to be the constant C squared times n? Yes? One more, well actually, a couple more steps. Because now what is this? This is verbatim. Property number 1, isn't it? Property number 1, that's A minus B over n times the summation of the I is n times n plus 1 divided by 2. And I said that's pretty good, but the other thing we'll be doing on the next little example I do here is looking to cancel, simplify. You see anything? Don't the ends cancel here? And so I wind up with a minus b times n plus 1 divided by 2 plus c squared minus b. So anyway, stuff like that is what we're going to do. One-time example, but it pays off. So wanted to show you those, and then we'll use those here.